We'll proceed in summation to integral calculus. Summation to integral calculus, at the beginning, it looks very difficult. How I can divide my problem into n number of parts and then solve it. From the top perspective, from the higher perspective, it looks very difficult. But many times, difficult things they work in difficult time. Difficult things they only work in difficult time. Whatever we feel that is very easy, probably they will not work in very difficult time. And people should be prepared for the very difficult time. Okay, we are taking example. Okay, so we are taking example of a kind of a set of coin. I have I have n number of coins. I have n number of coins. Okay, I have n number of coins. I have n number of coin. Coin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have n number of coin. I throw the coin. This is what in the last video we talked about. I have n number of coin and I throw the coin. Exactly like this example is not available. Loosely related to this example is available because solution is easy. But to extent we are talking, to this extent example is not available because solution is tedious. Okay, now I have n number of coins. If I have n number of coins, then I throw the all coins. If I throw all the coin, there is a highly likely that I'll get some number of head and rest number of tail. I'll check coin by coin. If it comes tail, then no problem. What is no problem? I have some money. Okay, so I have some money in my hand. I have some money in my hand and I have tons of coins also. Okay, I have money in my I have money in my hand. Okay, I always keep these two money. So consider I have 10 dirham. It is not dollar. It is 10 dirham. This is the currency of the United Arab Emirates. This is old note, new currency. This is kept for a long time. This is probably old note, may not be in circulation. So this is currency for the Dubai. Earlier, till some time back, I believe 40 years back or something like that, the currency of United Arab Emirates was Indian rupee one. But anyway, now I have three coins in my hand. I have three coins in my hand. Coin number one, coin number two, coin number three. Now I just throw it. I just throw it. Then I check the coin by coin. If coin is head, if coin is head, then this currency will become double. If I get head and tail, then this currency will become double. If it is 10 dirham, it will become 20 dirham after seeing the first head. Then after seeing the second head, whatever right now I have, that is 20 dirham, will become 40 dirham, again double of it. Then I see third coin, that is tail, no problem. Multiply by 1 1. Whatever we have, we just carry upon. So tail is not is multiplying factor for the tail is 1, whereas multiplying factor for the head is 2. So if I get 2 head, then it will multiply 2 times. 10 to 20, 20 to 40. With 2 to the power number of head, it will multiply like that. If I have n number of coin, and if I pass this dirham against each coin and then pass it across, what is the new value of dirham? This is the question. Okay, what is the new value of dirham? If I cross this dirham through series of coins, I throw a number of coins. and I cross this dirham through series of coin, and then coin by coin, coin by coin, coin by coin, it becomes double, double, double. If it is tail, then no problem, nothing happens. Then double, tail, nothing happens. If it is passes through, what is the new value of dirham? Someone would say it depends. How many head are there? Then someone would say, okay, what is the number of head you get? Number of head depends upon the luck. Okay, there is no luck. What is the number of head we will get? Okay, then is there a way to calculate how many heads we will get? Okay, if I know how many head we will get, guaranteed, this is called average, mean. If I throw many times, then I start counting the number of head. Okay, and then I average it. This is called frequentist model. Frequentist model means I'll see the frequency, how many head are coming in each time, their maximum time or whatsoever, or I'll average it, and that is the number. That is the one way. Okay, what are the other way? Whatever the ways, concept is that can I estimate number of head if I throw a n number of coin only one time? Do whatever mathematics you want. You can throw 50 times, 100 times, 1000 times, do any mathematics, whatever it is. When it comes to on the table, you have to throw only one time, and then tell me that what will be that this 10 dirham value will be. It is luck. It is not a luck. That is the answer. It is not a luck. Then what it is? Okay, someone would say that, okay, now there are n number of coins, right? And all coins are independent to each other. The outcome of one coin is not dependent upon other coin. Why can't you divide into n different parts? Okay, and toss one coin, and through that coin, you think about what will be your dirham value. Amazing, amazing. Oh, not possible. How come it can be that easy? Okay, I have n number of coin, and I don't know how many coin will turn head, how many coin will turn tail. Okay, if I divide n number of coin into n part, then I come to know only one coin. I have only one coin in my hand. If I divide my problem into n part, for this part, just assess that what will be the multiplier of your dirham. If you have 10 dirham, and if you toss this coin, then how much dirham will pass through? Okay, this is input, this is media. If I talk in electronics term, if I talk in telecom communication term, this is the media, this is electronic signal. And electronic signal is passing through this media. And then what it becomes? There also probability and stochastic comes into the picture, the nature of the media. What is nature of this single coin? If this dirham passes through, then how much it will become? If this dirham is C, if it is C and it becomes alpha, then it is modified by alpha by C. Makes sense? If the input side is C dirham, and when it is passing through a media and it becomes alpha, then modification is happening alpha by C. Okay, this is called modification factor. So this media, that is the coin, it is modifying it by alpha by C. Means C into alpha by C, that is alpha, that is becoming like this. Now I know that one particular coin can change input by alpha by C. Now, if this alpha will pass through another coin, then alpha will be multiplied by alpha by C again, because that is the multiplying factor. Then it will pass through another coin again. Whatever is result of the second coin, it will get multiplied by alpha by C, because that is the multiplying factor each coin is carrying on. And then after n number of coins, probably it will be alpha by C to the power n. That much will be the value of C entered through C and exiting through C into alpha by C to the power n. C into, in bracket, alpha by C and on top of bracket to the power n. Okay, I can't believe. It cannot be that easy. It cannot be simply that easy. Means I have a set of n number of coin. How many coin you have? 10,000. 10,000. Try throw 10,000 coin, and with every head try to multiply it. With tail, don't do anything. Multiply by 1 and try n number of times and see, and then average it. Person will say, if I count 10,000 and with every head I start multiplying it in 10,000 only, I will I will go through some medical treatment. What I'll try many times. Okay, can you try one coin and tell me? Yes, yes, certain. Only one coin you need. This is called dividing problem into n different parts. Solve part by part. Solve part by part. And then sum it, or here we are multiplying it because arena is of and or relationship that we are talking in probability. Here arena is and we have to multiply and it will become alpha by c to the power n. Okay, sir, thank you very much. What is your alpha by c? You tell. What is your alpha by c that you tell? Okay, now we will proceed in that. Let's go back to our patent example. Patent example is that how many students, if number of a student in a class are n, there are n number of students, they are studying in a class, and consider that they get marks from 0 to 10. Okay, there was an examination in mathematics. Okay, there was an examination in mathematics, and n number of students, they got marks from 0 to 10. Some student got 0, some student got 1, some student got 2, some student got 10 also. Okay, student who were studying in their room, they got 10 marks, but student who were roaming around around in near the cinema theater, so I have seen many students, they enjoy cinema, okay, movie. So students who were roaming around the movie theater, so they got 0 marks. A student who were roaming around the book, they got 10 marks. In between, now you can understand what people were doing. So because God has given equal brain to everyone, irrespective of the community, religion, or black, white, skin color whatsoever. Everyone is same intelligent. Okay, only depends upon how you invest your time. You invest your time in study, or you invest your time in movie theater or whatsoever. It is up to you. Okay, now when I'm going, now the question is arising: what is the average marks of the class? What we are trying here? If I have n number of coin, if I throw it, I'm trying to find average number of head. This is what I'm trying. If average number of head is alpha, then I have to do c into alpha to the power. I'm sorry, c into, that is the initial currency, c into 2 to the power alpha. If there are 2 head is coming, 2 to the power 2, it will be multiplied by 4. If there are 10 heads coming out of n, then c into 2 to the power 10. Okay, so concept is to find the average number of heads. How many average number of head I can estimate? Okay, in that fashion, okay, you're trying on the experiment in front of everyone, whatever mathematics you did, and there it comes no head. Then you thought that it will come alpha number of heads, right? And you are showing to everyone, I used a mathematics, and in that mathematics, I know that alpha number of head will come. Now you are showing in front of everyone, and it comes no head. Then, okay, think in that fashion. Now there is a gaming machine. A machine is a gaming machine, and this is the scenario is placed. How many numbers of head you get, your money will get doubled. How many tail you will get, your money will become half, or your money will become one third. Okay, should you play or not? That is the question. Probably first time you will lose some money, but you have calculated the probability, and average number of head is more, or average number of head, that is the media, and your currency passes through the media. Currency passes through the media, it will be more than C average. Keep playing. Play one time, two time, three times. On an average, you will earn the money. If this is called the probability. Anyway, what is the average marks of a class when I know students may get 0 to 10? One way is that you ask every student mark. Take a notebook and ask every student marks, and then add all the marks, divide by n. What is another way? Take a take marks x, take marks x, take marks axis. This is 0 marks and this is 10 marks. This is 0 marks, 1 mark, 2 mark, 3 mark, 10 marks. Now you ask students, you stand up, whoever has got 0 marks. Some students who are shameless, means they have never studied in their life, they got 0 marks. So 0 marks, I'm saying shameless for time being only. Now once they go and start studying, then they will become meritorious students. Everyone has now a concept of changing it. It is up to the student what he wants. He wants cinema theater or he wants the marks. Okay, so 0 marks means now now he is right. How many students? Consider 4 students are standing up and in the 0 mark. Now he took a axis and against 0 he made 4 students. Now this is the marks axis and this is the number of student axis. Against 0 number of students are 4. Against 1 number of students are 20. Against marks 2 number of students are 10. Against marks 3 number of students are 5, like that. Okay, so he is writing. Now against marks number of students are 20. Against marks 2 number of students are 10. Against marks 3 number of students are 5, like that. Okay, now he has taken a notebook. Now he is saying how many students have got 1. Students are standing. 20 number of students are standing. How many students got number 2? 2 marks. Like that. Now he is writing in his notebook. 0 into 4, 1 into 20, 2 into 10, 3 into 5. Like that he is now writing. Adding it and then dividing it by n. That is another. That is far more easy. That's why I say mathematics makes sense. Okay, how easy it is. Probably he can do it in 1 minute only. If n number of, consider n is 200. Now asking each student and marking on the notebook 200 students, it will take 1 hour time, 2 hour time, 3 hour time only. In 1 minute he can carry only 10 times he has to ask the student to stand, 11 times. That's it. And then he will learn. There is one more guy. He is even smarter. Now he is saying how many students got 0 mark? 4 students are standing. Now in the 0 mark he is writing 4 by 10. 4 by 10. In 1 mark 20 by 10. Okay. In 2 mark 10 by 10. I'm sorry, 10 by n, 20 by n. In 3 marks 5 by n. Okay, now he is writing on his notebook 0 into 5 by n, 0 into 4 by n plus 1 into 20 by n plus 2 into 10 by n plus 3 into 5 by n plus. Just add it and you get the average mark. Because whatever you had divided by n, afterwards you are dividing in each go only. So it is ready-made solution. This is called probability mass function. This is probability mass function. What is average mark? This is how you calculate the average mark. How to calculate average head? That's why book does not have the solution. Whatever is available solution I have seen in the book. Whatever no one would understand it. Sometimes you have to think in reverse fashion. Whenever you are not finding the solution what you are looking for, you have to see in reverse fashion. What is reverse fashion? We are seeing the marks and then we are drawing the probability. Can you go other way? What is other way? I have a dice. I have a dice, and it has 1 to 6. In Ludo, I have played Ludo many times. Okay, there is a snake and ladder. Okay, and 99 will be snake. You have to go from you have to start. If you get 6, then you can enter into the snake and ladder game. Otherwise, you have to be at the 0.1. Then you have to start from 1. Okay, you get 6 and 1. Then you have to start with the 1 because now with the 6 you can enter. And then with ladder here and there, quickly you reach 99. In 99 there will be snake. Between 91 to 100 there will be 3-4 big snakes. Okay, if you get 99, then you will come down to 6 or 7 only directly. From 99 to 7 you have to start again. Okay, that is the concept of care. Anyway, now I have a dice and it goes 1 to 6. Oh, thank you very much. I have another dice that goes 0 to 10. Makes sense? I have a dice that goes 1 to 6. Okay, let's go with the 1 to 6. Now, if I draw the dice, it comes 1. Oh, it came 1. What do you want? Oh, it came 1. Okay, if it comes 1, I have many currency. I have 11, I have 6 currency in my hand. Okay, I have 6 currency in my hand. This is dirham. This is Nepali rupee. Consider I have 6 currency in my hand. Now, if it comes 1, then I will double it. Dirham will get doubled. This is at slot number 1. Slot number 2, slot number 3, slot number 4, slot number 5, slot number 6. There are 6 currency like this. I have a dice and I throw it. If it comes 1, then slot number 1, it will get doubled. If it comes 6, the slot number 6 will get doubled. Now I throw only one time. Now tell me that what is the new money for each slot? I throw only one time. What is the money? Money. Now, if it comes 1, then this dirham will become double. If it comes 2, then this Nepal. This is also 10 rupee only. If it comes 2, then it looks very elegant. If someone sees Nepali rupee, it looks like old Indian 100 rupee. It is extremely elegant. Extremely elegant. If someone watches Nepali rupee, it is extremely elegant. Okay, sometimes I feel like it is an Indian 100 rupee earlier. It is that elegant. Anyway, dirham also very elegant. Anyway, now if someone is getting 2, then Nepali rupee becomes a double. Now question is arising that now I have some calculation. Okay, I did some calculation. Now I throw the dice only one time. Okay, tell me what is the new money that out of this 6 slot money I can expect? It depends upon the throw. What you get? No, you tell me. That is the question. This is called other way. You make the dice, you throw the dice, whatever comes, then you change something. Make sense? Now dice has probability. Each one probability is 1 by 6. If I throw 6 times, then there is a chance that 1 will come once. If I throw 6 times, the 6 will come once. If I throw 1 time, then each will come 1 by 6 times. The probability of coming is 1 by 6. Makes sense? Okay, if I say that I have a dice and written 1, 2, 3, 4, 5, 6. If I throw 1, then 1 to come, probability is 1 by 6. 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. If it come 1, then what is the probability? If there are marks, what is the probability against 0? 4 by n. Against 1, 20 by n. Against 2, 10 by n. Against 3, 5 by n. I believe this is how we proceeded. Makes sense? Now, if I throw a dice, then what is the probability that I'll get 1? I'm coming from top side to bottom side. The example what we give, that was marks was made, and from there we got the student. Students have probability. Now we are coming from probability to marks. Makes sense? Sometimes we reverse the solution. Now dice 1 has probability of 1 by 6. If it is 1 by 6, if it is 1, then I double. If it is 1, then I double the dirham, that is the slot number 1. Twice, I make it twice. If it is 1 by 6, then if it was 1, then it will become double. If it is 1 by 6, then the 2 into 1 by 6. Make sense? Okay, if I throw a coin, then all currency have equal chance to become a new currency. What is that? What will be the new currency? That is 2 into 1 by 6, 10 into 2 by 6, 20 by 6. Okay, that will become, I believe, up 3 point something. Our currency will become 10. Earlier it was 10, they will become 3 point something. This is the called, this is called average movement. What is the average of this currency for each currency? Try same thing here. Okay, if a student, if now there are, now take a dice, take a dice. Now dice has 0 to 11. This dice has 0 to 11. 11 faces are there, 0 to 11. What is probability that 0 will come out? 1 by 11. 1 will come out, 1 by 11. 2 will come out, 1 by 11. If 0 comes out, if it 0 comes out, then what I will do? If 0 comes out, then I will proceed something 0. Make sense? If 1 comes out, then I'll proceed something 1. Make sense? I have one coin. I have one stone. If 0 comes out, then I'll move a stone 0, 0. Step by step, I have to move the stone. Okay, so I'll move the stone 0 step. If 1 comes, then I'll move the stone 1 step. If 2 comes, then I'll move the stone 2 steps. If 3 comes, I'll move the stone 4 steps. Make sense? Now tell me that if I throw this dice one time, then what is the position of your stone? Make sense? If it comes 10, then I will move a stone 10 steps. If it comes now depends. Now tell me what is the location of your stone if I throw it one time. Okay, it depends upon the probability. Okay, what it will be? Probability of everything is equal. Equally it will come. Then moving every stone 0 time, 1 time, all have equal probability. Okay, then you have to add it and divide by, you have to add and divide by 10. Probably it will come near to 5. So stone will move 5 steps because that is the average. No, no, no. If probability is different, then whoever has more probability, the stone will move towards that more. Okay, if 0 has full probability, if you throw a dice 0 to 10 and every time it will come 0 only, then it will not move. Every time it will come 10 only, then you can expect it has moved 10 steps. Every time it will come 5 only, then it has moved 5 steps. Half of the time it will come 5, half of the time it will come 10, then it will move 7.5. Okay, means movement depends upon the probability. This is what we are doing here. What is the probability the dice will come 10 times? 10. Dice is 0 to 10. What is the probability that it will show 10? Then how many students have got 10 marks? Okay, that one. What is the probability it will come 3? Then it is 5 by n. What is the probability it will come 2? Then it is 10 by n. What is the probability that it will come 1? Then it is 20 by n. Okay, now start it. Probability and what you will do. If 0, then probability is 5 by n. 5 by n into 0. That much you will move. Okay, if it comes 1, for 1, the probability is 20 by n. Into 2, you will move 2 steps. If its probability is 1, then you will move 2 steps. If probability is 20 by n, then 20 by n into 2. Plus, you want to calculate the average, right? Now, whatever you are getting, just add it and you will move that much step. Makes sense? Okay. The concept is, the initial question is, if I throw n number of coin, then what is the average head count I will get? For that, we are trying for the single coin. We try with the single coin and try to find out what is the multiplication factor. Now, if I try to find multiplication factor, first we'll go other way. If I toss a coin, then how many things will come? It will come 0 or 1. It will come head or tail. If I toss a coin, either it will appear head or tail. Okay, what you will do if it appears head? What you would do if it appears tail. Oh, if it appears head, I will double my rupee. I will double my currency. Oh, if it comes tail, then I won't do anything. My rupee will be multiplied by 1. If it comes head, then my rupee will be multiplied by 2. Okay, very nice. Now you tell me what is probability of getting zero head. Now there are only two chances. If I throw a coin, there are only two chances. Head will be 0 or head will be 1. There are only two chances. Head will be 0 or head will be 1. Okay, I can, rather than saying head and tail, I can write 0 and 1 on the face of coin. 0 and 1 or 1 and 2. Like a dice. Dice is written 1 to 6. This is coin is a dice only where written is 1 and 2. Okay, if it comes 1, then you have to multiply by 2. If I'm sorry, I think it is better way. If it comes 1, that is tail, then you have to multiply by 1. If it comes 2, that is the head, then you have to multiply by 2. Makes sense? Whatever currency you have to multiply by 2. Okay, thank you very much. Now let's try. Okay, what is the probability that you will get? What is the probability that you will get one tail? You will get one tail. Okay, probability is 1 by 2. Probability is 1 by 2 into 1, because you won't do anything, multiplied by 1. Okay, plus the way we calculated the average marks of the class, we are trying to calculate average head now, or what average marks of the class when we were trying. Now we are trying to calculate average multiplying factor. If it comes 10, then probability is 1 by 2. Then in that case, it will be multiplied by 1 plus the way we did probability into multiplication factor plus another probability into multiplication factor. Another probability is again 1 by 2. That will come 10. Then it will be multiplied by 2. This is the net multiplication factor. Average multiplication factor. What it is? 1 by 2 plus 1, 3 by 2. We did it in the last session. 3 by 2. Okay, what is guaranteed is 1 by 2. Consider the getting head is P. If I toss, then getting head probability is P. Then getting tail probability is 1 minus P. Okay, let's write in this fashion. Now, how many heads are coming? Let's go with this fashion. Okay, I will multiply by 2. Then we will write summation x equal to 0 to 1, where x is number of head. Makes sense? When x is number of head, okay, to 1, summation of x equal to 0 to 1, because only two things appear. Head can be 0 or head can be 1. Now I am doing more into mathematics. Actually, it should be what is the probability of tail and what you would do if tail comes. In a student's case, what is the probability of getting 0 into what you would do, plus what is the probability of getting 1, then what you would do, plus what is the probability of getting 2, what you would do. If you add all, then what you would do will come into the picture. Make sense? If it comes 0, then I'll multiply by 0. If it comes 1, like a student average, for 1, then what is probability of 1? That probability into 1. Then if it comes 2, then what is the probability into 2? Silently, these are the marks and that is the probability. Okay, if you add all, you get the average marks. Okay, if it comes head, what you would do? If it comes tail, what you would do? Currency, I will multiply by some factor. Here also, I will multiply by some factor. If you add, you will get average multiplication factor. If you know average multiplication, then you can estimate something. That if I toss a coin, then what will be the average multiplication factor? Makes sense? Because multiplication factor into toss probability plus multiplication factor into toss probability, marks into marks probability, marks into marks probability, marks into marks probability. If you add average mark, multiplication factor into multiplication factor probability, multiplication factor into multiplication factor probability. If you add, you get average multiplication probability, or average multiplication factor probability factor. Okay, we'll try here. Now to go tail and head, now we will say how many heads are coming. Head can be 0 or 1. Oh, summation x equal to 0 to 1, where x is head. Okay, what is probability of getting head and what you will do? Sum it for all the head. Head is 0, what you do? Head is 1, then what you do? What you would do and what is the probability of it? Sum it, you get what you want. For a coin, there is only two cases. Head is 0 and head is 1. X equal to 0 to 1. Okay, if x is 0, x is whatever it is, what you do? Oh, if number of head is x, then I will multiply by 2 to the power x. Okay, that is the case. If x is 0, then I'll multiply by 2 to the power 0. Means I want 2 to the power 0, that will come as 1. Okay, and what is the probability of getting 0 head? That will be 1 by 2. Someone can try. 1 by 2 means it will be 1 by 2. If x is 1, then 2 to the power x. 2 to the power x. Then it will be 2 into 1 by 2, 3. Okay, if probability of getting head is p, if it is p, then what will be the, if head is 0, x is 0 to 1. If count of the head is 0, then the tail is 1. If count of head is 0, then tail is 1. I'll rewrite it. I'm not running away. I'll rewrite it. Summation x equal to 0 to n, where x is number of head. What you would do? 2 to the power x, because x is number of head. I'll raise by 2. 2 to the power x. If x is number of head, there is a hidden there something called number of tail. Number of tail is n minus x. You will do 1 to the power n minus x, because we are not doing anything here. So it is 2 to the power. Now you can write a Python function. Okay, what you will do if it comes head, what you do if it comes tail. Now summation x equal to 0 to n, where n is number of chances. Here it is 2. Here it is 1. Means you can toss only one time. Okay, but number of head that is appearing, I'm sorry, 0 to n means x is 0 to n means how many head, x is what? X is head. How many head you are expecting? Head can be 0, head can be 1. When head, okay, inside this, what you do if x comes? Then I will do 2 to the power x. There is a hidden thing there. If number of head is x, then number of tail is n minus x. Then summation x equal to 0 to n, 2 to the power x, and then what you do with the tail? 1. You are not multiplying anything. 1 to the power n minus x. Okay, NCX, this is binomial distribution. We have talked about it very, very in detail in the previous 2 or 3 videos. Okay, now it is NCX. P is the probability of getting head. P to the power x. 1 minus p, that is probability of getting tail. 1 minus p to the power n minus x. If you add it, you get exactly what is the multiplication factor with 1 point. Okay, how much it will come? It will come as, first it will come as 1 into p. 1 into p to the power 0. 1 minus p to the power 1, it will be there. Hop. First time it will come as 1 minus p. Okay, next time x equal to 1, then it will become 2. 2. Okay, and then NCX. N is 1 here. NC 0, NC 1, all will be 1. If x is 1, 2 to the power 1. 1 to the power n minus x is always 1. That is tail. What you do with the tail. 2 into p to the power 1. That is 1. You will do 2p. 2p plus 1 minus p. P plus 1 is the multiplication factor for a currency if you toss a coin. 2p plus 1. What about if P is 1 by 2, unbiased coin, then 3 by 2? Every time you toss a coin, the currency will become 3 by 2. If you double the currency, if it comes head, and you don't do anything if it comes tail, then every time it will be multiplied by 3 by 2. Now I divided the problem into n parts. If there are n number of coins, then 1 plus p to the power n, that much multiplication factor will come with the currency C. Are you sure about it? Yes. Was it that simple? If I throw n number of coins, then what will be the multiplication if I pass a dirham? If I pass a dirham to n number of coins that I have tossed in one go, and with a head it will become double, and with tail nothing will happen. If it comes out, then what is the new dirham amount? If it is 10, then what will be new amount? If it is C, then what will be new amount? C into 1 plus p to the power n. Oh, not possible. It cannot be that. That is the concept behind dividing the problem into n different parts. Hope dirham got. This is the concept of dividing the problem into n different parts. Okay. Understood. If you divide your n number of coins into n number of parts, with each coin you will multiply with 3 by 2 or 1 plus p if it is a fair coin. Depends upon p. Okay, that is the probability of head. If probability of head is more than 1 by 2, then multiplication will grow beyond 3 by 2. If it is less than 1 by 2, then multiplication will shrink from 3 by 2 to less. If it is number of probability of head is 0, then 1 plus p, 1. Nothing will get multiplied because always it will come tail only. Okay, thank you very much. Can you prove it? If I throw n number of coins, the multiplication factor will be 1 plus p to the power n. Can you give one example? Will you prove it? Okay, what is the solution? Tell me. What is the solution if I throw n coin? It is not mentioned in any of the book. No one is dare to write this equation. What will be there? It is same thing. What is same thing? Number of head. Okay, what is number of head? Here, number of head is 0 to 1. Yeah, this is 0 to 1. If there are n number of coins, then number of head will be 0 to n. Yes. Then summation x equal to 0 to n. Okay, then probability of getting head into what you would do. Makes sense? Okay, thank you very much. Can you proceed? Summation x equal to 0 to n. That is the number of head I expect. With 0 head, if there is a 0 head, if I toss n number of coins, if there is a 0 head, then what you do? If head count is 1, then what you do? If head count is 2, then what you do? Head count probability into what you do. If you add all, then you will get the what you do average. What you do average. What I do if it comes head, I'll double it. Okay, now if it comes 2 head, then it will be 2 to the power x. If it comes 3 head, then 2 to the power x. X is 3 now. If it comes 4 head, then 2 to the power 4. 2 to the power x. Not right. Summation x equal to 0 to n. Okay, x is number of head. If it comes x head, what you do? Summation x equal to 0 to n. What is the probability of getting x head? Into what you do? 2 to the power x I will do. I will multiply my currency. I'll multiply by currency by 2. Means 2 to the power x if x head comes. Summation x equal to 0 to n 2 to the power x. There is a hidden n minus x tail also. If there is x head, then n minus x tail will also come. That people they do not think. That's why it is not there in the book. It's not there in any of the book. This example probably is available, but this solution is not available. Summation x equal to 0 to n, where x is number of head. Then what you do? 2 to the power x. This is what you do. What you will do with the tail, that is n minus x. 1 to the power n minus x. I'm not doing anything. What is probability of getting head? That is ncx p to the power x 1 minus p to the power n minus x. If I solve it, I'll get the number. I'll get the multiplication factor for the n coin. Yes, it will come 1 plus p to the power n. Yes. Okay, try summation x equal to 0 to n 2 to the power x 1 to the power n minus x, because 1 is what I do if it tail comes. I do nothing. Multiply by 1. 1 to the power n minus x. Now what is this is what I would do. Okay, what is the probability? Probability ncx p to the power x 1 minus p, that is a tail probability, 1 minus p to the power n minus x. No one can solve it. So try solving. It is very difficult. We will see if I can do it through integral calculus. But it is okay. Can you take some example and show it if it really comes? Let's take two coins. Make sense? Let's take two coins. Then how much head will be? X equal to 0 to 2. X will be 0, head will be 0, 1 and 2. Let's try with the 0. If it is 0, then 2 to the power x, 1. 1 to the power anything is 1 only. nc0, that is 2c0. It will come as 1 only. Okay, p to the power x 0. 1 minus p to the power 2 will come. 1 minus p to the power 2 will come. So someone can write now, it will be 1 minus p to the power 2 plus. This is for x equal to 0. When x equal to 1, then when x equal to 1, then it will be 2 to the power 1. That is, next is 1 only. 2 to the power 1. 2c1, that will be 2. So 2 into 2. 2 into 2. P to the power 1. 1 minus p to the power 1. 4 into p into 1 minus p. Now we have 1 minus p whole square plus 4 into p into 1 minus p. When x equal to 2, then it will be 2 to the power 2. It will be 4. 2c2, that will be 1. P square, 1 minus p to the power 0. It will be 4p square. Now someone can try 1 minus p whole square plus 4p into 1 minus p plus 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 4p square. If it will come 1 plus p to the power 2. Okay, someone can try. Let's try p equal to 1 by 2 for simplicity. P equal to 1 by 2. Then 1 minus 1 by 2, that will come as 1 by 2. 1 by 2 whole square, that will be 1 by 4. First will be 1 by 4. Next will be 4 into p into 1 minus p, that will be again 1 by 4. 4 into 1 by 4, that will come as 1. So 1 by 4 plus 1. Next is I believe 4 into p square, that will be 1 by 4. Again 1. 1 plus 1, 2. 2 plus 1 by 4. Okay, what was yours? 1 plus p whole square, right? 1 plus p to the power n. What is 1 plus p? That is 3 into 2. 3 into 2 square, that is 3 into 2 into 3 into 2. That is 9 by 4. And here it is 2 plus 1 by 4. 9 by 4. Oh, okay. Try with n equal to the number of coin is 4. Then we see, okay, we tried with the single coin, dividing problem into n number of parts. Then it is 1 plus p to the power 4. That is 3 by 2 to the power 4. If it is a fair coin, p equal to 1 by 2. It will come as 3 by 2 into 3 by 2 into 3 by 2 into 3 by 2. That is the multiplying factor. That will come as, I believe, 81 by 16. 3 into 3, 9, 27, 81. 81 by 16. Will it come 81 by 16? We'll try and we'll close it. We will do more thing later. Then we will close the discussion. Anyway, now x equal to 0 to 4. When it is 0, then it is 1, everything. nc0 is 1 only. 4c0 is 1 only. 1 minus p to the power 4. That will come as 1 by 2 to the power 4. It will come as 1 by 16. 1 by 16. Now x equal to 1. Then 2 to the power 1. 4c1. 4c1 will come as 4 1. So 2 into 4, that will be 8. And next will come as 1 by 16 only. So it will be 8 by 16. Okay, first is 1 by 16 plus 8 by 16. Now x equal to 2. So now it became 9 by 16. Total it became 9 by 16 actually. Okay, now x equal to 2. Then 2 to the power 2. It became 4. And 4c2 will become, I believe, 6. Then it will become 24. 4 into 6, 24 into 1 by 16. 24 plus 9, it will become 33, I believe. 33 by 16, 2 to the power 2. And then 4c2, 4c2, 2, it will become 6 1. Anyway, now when x is through 3, 2 to the power 3, it will become 8. 4c3, 4c3 will be 4 1. 8 into 4, 32. Here we have, I believe, here we have 33. 33 into 32, there will be 1 by 16 1. 32 plus 33, how much it will become? I believe it will become 65. Now we have 65. Now x equal to 4. If it x equal to 4, 2 to the power 4, that is 16, I believe. 4c4, that is 1, and that is 1 by 16 only. So what is 60? 65 plus 16. 65 plus 16 is 81 only. Means it holds true. We can divide our problem into n part and solve one part and do the summation. It works. This is what summation to integral. Now next question is arising. Can someone solve it for n where n tends to infinity? There we need integral calculus. Otherwise, if someone has caliber, he can solve it and he can bring summation x equal to 0 to n 2 to the power x, 1 to the power n minus x, ncx, p to the power x, 1 minus p to the power n minus x as 1 plus p to the power n. If someone can try it, okay, I'll see if it can be brought into integral calculus. Okay, someone can try solving it. This is not available in any of the book. Anyone can try. How to break problem into n different parts. What is the prerequisite of it? If someone is breaking problem into n different parts, make sure that each part are independent of each other. Each part should be identical and independent to each other. This is also called IID, identical and independent distribution or division. If someone is able to make it, because I know each coin is independent of other. Whatever the outcome is coming on every coin, they are not related to another. They are not dependent upon outcome of any other coin. If I can divide problem in n number of parts like this so quickly, 1 plus p to the, no one can, person will sweat getting ncx 2 to the power x, 1 to the power n minus x, I'm sorry, summation x equal to 0 to n, 2 to the power x, 1 to the power n minus x, ncx p to the power x, 1 minus p to the n minus x. What is next here? Next is consider if someone is getting 10, his money is becoming 1 by 2. We will do that also. If someone is getting 10, money will become 1 by 2. Okay. If someone is getting head, then money is becoming n times more. If someone is getting 10, his money is becoming alpha time less. Anything. This equation will work what we have shown. Consider if it comes head, then money will become alpha times more. If it is getting tail, money will become beta times less. Then summation x equal to 0 to n. Okay, alpha to the power x, beta to the power n minus x, ncx, summation x equal to 0 to n, alpha to the power x, beta to the power n minus x, ncx, p to the power x, 1 minus p to the power n minus x. Sum it. You get for the n. Why to do that much? You divide into n part and you get it. This is dividing problem into n part and achieving solution through summation. What is next? Integration. What is next? Vector. Okay, we can use a vector also in solving the integration. Okay, sometimes we feel that integration is insufficient, then we use vector. Okay, that is more than sufficient. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. plus 91 is the India country code. 9483160610 is the telephone number. Okay, Indian subcontinent is very big.